The modern landscape of firearm ownership requires a deeply analytical approach. We live in an era where supply chains are unpredictable, and the cost of maintaining a defensive posture demands that every dollar spent translates into uncompromising reliability. A firearm is not a novelty, it is a defensive tool and a mechanical lifeline. Yet the market is saturated with platforms that trade time-tested engineering for manufacturing shortcuts or conceptual gimmicks. When assessing a rifle, shotgun, or pistol, we must demand surgical precision, superior metallurgy, and absolute mechanical certainty. Welcome to Gun Sage. Today we are analyzing 10 firearms that possess fundamental flaws in their design, geometry, or material construction. Platforms that will ultimately leave the serious shooter with profound regret. We will examine the historical context of these weapons, dissect their mechanical shortcomings, and explain exactly why they fail to meet the standard of a reliable, heritage-quality defensive tool. The foundation of American marksmanship was built on the push-feed bolt-action rifle, a design perfected throughout the 20th century to offer unparalleled lockup and accuracy. Preppers and hunters often seek a budget-friendly entry into this legacy, which leads them to our first compromise platform, the Remington 770. While it carries a legacy name, this rifle was engineered purely for cost reduction, completely abandoning the proven cylindrical receiver design of the legendary Model 700. Instead of a hardened steel receiver, the bolt of the 770 locks directly into the barrel extension. Operating the bolt reveals a notoriously stiff, gritty friction, lacking the glass smooth travel required for rapid follow-up shots. Weighing 8.5 pounds with its factory optic, and utilizing a standard 1:10 twist rate within its 22-inch barrel, it struggles to maintain a 3-minute of angle group. The fatal flaw extends to the polymer components. The hollow stock flexes under the weight of a bipod, throwing off barrel harmonics, while the low-grade plastic magazine catch is prone to snapping in freezing temperatures. What is marketed as an affordable entry into precision shooting is, in reality, a disposable rifle with compromised mechanical integrity. The search for a versatile close-quarters defensive tool often leads buyers toward the traditional double-action revolver, a mechanism celebrated for inherent reliability. However, attempting to force a single revolver cylinder to serve two drastically different ballistic masters results in the Taurus judge. This weapon was conceptually designed to offer the devastating spread of a shotgun within the footprint of a heavy 29-ounce sidearm. Mechanically, the double-action lock work is standard, but the internal geometry of the cylinder is deeply flawed. To accommodate 3-inch 410 shotgun shells, the cylinder is massively elongated. When a shooter loads a standard 45 Colt projectile, that bullet must travel an absurdly long distance, a massive freebore jump, before it ever engages the rifling of the short 3-inch barrel. This jump bleeds off critical chamber pressure and physically destabilizes the projectile, resulting in sluggish muzzle velocities hovering around 850 feet per second and practically non-existent accuracy past 15 yards. Furthermore, firing birdshot through a rifled barrel imparts a severe spin on the shot cup, creating a hollow, donut-shaped pattern that is mechanically ineffective for serious defensive applications. Moving from the realm of handguns back to modern tactical long guns, we examine a platform born from the Cold War necessity to arm rear echelon vehicle crews against potential armor threats. The original design was a masterpiece of compact engineering, but its civilian adaptation, the FNPS-90, is a prime example of how regulatory compliance can destroy a weapon's tactical viability. The genius of this platform relies on a straight blowback, closed bolt operation firing the high-velocity 5.7 by 28 mm cartridge. To meet federal civilian requirements, the barrel was extended to a cumbersome 16 inches. While this allows the lightweight 30-grain projectile to achieve a blistering muzzle velocity of 2,300 feet per second, it completely ruins the ultra-compact balance that defined the original personal defense weapon. At 6.2 pounds, the extended barrel makes the weapon feel awkward in confined spaces. The most egregious mechanical flaw, however, is inherent to its bullpup design. Connecting the forward trigger to the rear sear requires a long, flexible polymer linkage bar. This results in a heavy, vague 8-pound trigger pull with an agonizingly slow reset. severely hindering the surgical precision required in a modern defensive context. The pursuit of overwhelming firepower in a compact footprint also gave rise to the Kel-Tec KRSG. The pump-action shotgun has a storied military heritage, revered for its simplistic, robust battery of arms. The KSG attempts to reinvent this heritage by incorporating a dual-tube magazine system within a bullpup polymer chassis. While the ability to carry 14 rounds of 12-gauge ammunition in a 6.9-pound, 18.5-inch package is impressive on paper, the mechanical complexity required to feed from two separate rear-mounted tubes is a severe liability. The pump action demands an incredibly aggressive, perfectly executed stroke. Under the physiological stress of a defensive encounter, if an operator short strokes the pump by even a fraction of an inch, the intricate shell lifter will attempt to feed two shells simultaneously. This induces a catastrophic double feed that locks the breech entirely. Unlike a traditional shotgun, this malfunction cannot be cleared by simply racking the slide. It requires armor or tools and time to pry the deformed shells from the chamber. In a life-or-death scenario, this level of mechanical finickiness is unacceptable. The same desire to solve a specific problem with over-engineered complexity plagues the concealed carry market. The Sig Sauer PIT 365 SAS was engineered to eliminate the printing and clothing snag issues associated with daily carry. To achieve this smooth, featureless profile, designers completely removed traditional iron sights. Instead, they embedded a flush-mounted fiber-optic bullseye sight directly into the slide of this 17.8-ounce striker-fired pistol. Mechanically, the weapon functions on a proven short recoil system, pushing 115-grain 9mm projectiles out of a 3.1-inch barrel at roughly 1,000 feet per second. However, the sighting system creates a fatal blind spot. The fiber optic requires overhead ambient light to function. In the low-light environments where violent encounters statistically occur, the sight picture completely vanishes, leaving the operator visually disconnected from their defensive tool. Furthermore, to mitigate recoil, the barrel and slide are heavily ported. If an operator is forced into a close-quarters, compressed retention firing position, this porting directs a violent, superheated blast of high-pressure gas and unburned powder straight upward, potentially blinding the user in the middle of a lethal engagement. Recoil management is a legitimate mechanical hurdle, and the Chiappa Rhino attempts to solve it by fundamentally altering the geometry of the revolver. Instead of firing from the top chamber of the cylinder, the Rhino fires from the bottom. This radically lowers the bore axis, directing the recoil impulse straight back into the shooter's forearm. Pushing a high-pressure .357 Magnum cartridge at 1,400 feet per second from a 6-inch barrel, this 32-ounce revolver virtually eliminates muzzle flip, allowing for exceptionally fast follow-up shots. Yet the cost of this innovation is internal fragility. To enable the hammer to strike the bottom chamber, the internal lockwork relies on an absolute labyrinth of watch-like levers, microsprings, and transfer bars. The mechanical reality is that complexity breeds failure. If a single microscopic component bends, breaks, or becomes heavily fouled with carbon, the weapon is rendered completely inoperable and cannot be repaired in the field. For a collector, it is a fascinating piece of engineering. For a family protector demanding uncompromising reliability, it is an over-engineered liability. Our analysis now turns to platforms that attempt to leverage mid-century military heritage, starting with the pre-2005 Ruger Mini 14. This rifle was designed to capture the handling characteristics of the M1 carbine while utilizing the proven fixed piston gas system and rotating bolt of the legendary M1 Garand. At a highly maneuverable 6.7 pounds with an 18.5-inch barrel, it was adopted by ranchers and law enforcement as a rugged utility rifle. The fatal flaw of these older generation models lies strictly in their metallurgy and barrel geometry. Ruger utilized a notoriously thin, pencil-profile barrel with a 1-in-9 twist rate. The physics of this design dictate that as the chamber and barrel heat up after just a few consecutive shots, the thin steel undergoes rapid thermal expansion. This causes the barrel to aggressively whip and physically warp during the ballistic cycle. A rifle that initially holds a respectable group will suddenly open up to a massive 4 to 5 minute of angle, turning precise shots into unpredictable, dinner plate-sized spreads. Trusting a long gun that loses its mechanical zero the moment it gets hot is it a dangerous compromise? A similar desire to harness extreme power led to the development of the Desert Eagle and 50 Action Express. The concept was to chamber a semi-automatic handgun in a cartridge capable of delivering magnum rifle energy. To handle these immense chamber pressures, engineers abandoned the traditional Browning short recoil system and directly scaled down the gas-operated rotating bolt mechanism of the M16 battle rifle. The resulting firearm is a massive mechanical footprint, weighing an exhausting 4 pounds and 7 ounces empty. The 6-inch barrel generates a staggering 1,475 feet per second with heavy projectiles. The liability of this platform is the human interface. The gas system requires exceptional resistance to cycle the massive slide. If the operator fails to maintain a perfectly rigid, vice-like grip, a phenomenon known as limp wristing, the kinetic energy required for the extraction and feeding cycle is absorbed by the shooter's arms. This inevitably results in constant stovepipes and failure to feed malfunctions. It is a mechanical masterpiece of scale, but as a practical defensive tool, it is far too heavy and entirely too sensitive to user input. Continuing our examination of military heritage, we look at the Springfield Armory M1A standard. Picking up this rifle evokes a profound respect for American history. With its heavy walnut or synthetic stock and cold parkerized steel, it is the direct civilian descendant of the M14. Weighing a substantial 9.3 pounds unloaded, it utilizes a 22-inch barrel with a 1 in 11 twist rate to stabilize the versatile .308 Winchester cartridge. It operates on a robust short-stroke gas piston and rotating bolt. The mechanical reality of this platform in the 21st century, however, is one of high maintenance and strict ammunition limitations. To achieve and maintain sub-minute of angle accuracy, the action must be meticulously glass-bedded into the stock, a process that degrades over time and under heavy recoil. More critically, the operating rod of the M1A is historically sensitive to port pressures. Firing modern, high-pressure, heavy grain match ammunition can violently bend or derail the operating rod, catastrophically destroying the rifle's gas system. While its historical pedigree is unquestionable, modern operators often regret the weight, the difficulty of mounting modern optics, and the strict mechanical limitations of its operating system. Finally, we arrive at the platform that stands as the ultimate betrayal of mechanical heritage, the Century Arms VSKA. The foundation of this rifle is the legendary Kalashnikov long-stroke gas piston system. Historically, the AK-47 and its variants are recognized globally as the epitome of uncompromising reliability, designed to function in the most abrasive and unforgiving environments on Earth. The VSKA presents the aesthetic of this rugged Eastern Bloc history, featuring a 16.25-inch barrel, a 1 in 10 twist rate for the .30 caliber projectile, and weighing an even 8 pounds. However, underneath the sheet metal receiver lies an unforgivable mechanical sin. The front trunnion is the heart of the AK platform. It is the critical component that locks the bolt and absorbs the immense 45,000 PS1 concussive force of the 7.62 by 39 mil I-meter cartridge upon ignition. Historically, trunnions are milled from forged steel to withstand this violent stress. To cut manufacturing costs, the VSKA utilizes cast metal trunnions. Cast steel is inherently porous and brittle compared to a hammer-forged component. Under the stress of continuous firing, these cast trunnions inevitably develop microfractures. This leads to a rapid loss of headspace, and eventually, the rifle literally beats itself to death, resulting in a catastrophic, explosive failure near the operator's face. To take a design renowned for its indestructible nature and purposely compromise its most critical pressure-bearing component is the ultimate mechanical failure, making it the most regrettable purchase a serious shooter could make. The integrity of your defensive tools is not a matter of brand loyalty or aesthetic preference. It is a matter of metallurgical science and mechanical reality. The firearms we select must be proven, time-tested instruments capable of enduring the harshest conditions without compromise. I invite the veterans, the armorers, and the high-mileage shooters in our audience to contribute to this archive of knowledge. Share your first-hand experiences with these platforms or others that have fallen short of their mechanical promises. Your hard data and real-world observations are vital to this community's preparedness. Maintain your standards, respect the mechanics, and we will reconvene for the next detailed technical briefing.